and gents. Hopefully the homework wasn't too bad last night. I know we went through this stuff really, really quickly. So today, I really need you guys to buckle down. You need to pay attention to the video, going over these examples, and then I need you guys to make sure you're working with your groups, you're really understanding this, and you're getting the help that you need. And then we'll touch base again on Tuesday when you guys come back next week, and go over any of the holes, the gaps that we still have. Okay. All right. So polynomial functions, we have to always have them in standard form. So this is the form that looks rather complicated, but when you think about it in terms of the numbers and the x's, the variables, hopefully it makes some sense. So we have f of x is equal to a subscript n, x to the n, plus a n minus 1, x to the n minus 1, plus dot, 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 because we could have other things in there, x to the first, plus my constant, okay? So you got to understand that that is in standard form. Okay, so again, just write out a subscript n. That's always your leading coefficient. It is always a number. Okay? It's always just a number. Any a that you see, whether it's n minus 1, n minus 2, whatever it may be, it's just a number. Okay? And then a subscript 0, that's always your last thing. It's always your constant. Okay, just like y is equal to mx plus b, it's always your b value. It's always just that last number. Okay, it may be there, it may not be there. But either way, it's just your constant term. It's your last guy. So then n is always how you figure out what degree that your polynomial function is. And you always take the highest. Okay, which makes sense, right? Because we want everything included. We always want to take that highest number, okay? So the three things that you have to understand is what the degree is, what type of function it is, and then what the leading coefficient is. So we have those 5. We have the constant type, linear, quadratic, cubic, and the quartic. Okay, so 0 to 4. Just make sure you know those. Okay. Let's just talk about real quick classifying it as a polynomial or not. So if you have the function f of x is equal to 3x to the third, okay, is your coefficient, or all of the coefficients, are they real numbers? And here you only have the 1, you have 3, so that is a real number. Then you got to ask yourself, are your exponents whole numbers? Well, if it's x to the third, yeah, that's a whole number. So this is a polynomial, okay? Those questions work out to make sense. But what if I give you f of x is equal to 3x squared minus 2x to the negative x? Do you think this is a polynomial? So take a look at this for a second. We have 3x squared minus 2x raised to the negative x power. And hopefully a little red flag is going off in your head. This guy right here is basically why this is not a polynomial. Okay, first off, we never want to have x as an exponent. I want numbers there. I want to understand what's going on. And then we never want to have it negative either. Okay, we always want that x to be on top. We never want to send it down to the basement, down to the bottom. Okay, so that's why two things here in one make this not a polynomial. Okay, so hopefully that part on the homework was rather easy. Again, make sure you're checking with your group today about your answers and whether or not they match up. And then I left the answer key, so double check with that as well. And circle the ones that you have a question on. We'll go over those on Tuesday. Okay, then we went to basically evaluating these. All right, so we got to evaluate these things. So we have two different ways. Direct substitution, which is kind of a little bit longer, but it might be the easier route right now, and that's okay. But we've got to get better with the other one being synthetic. Synthetic is really just going to be quicker for you. That's the main reason why we do this. Especially when we get into dividing these polynomials, we want the quickest way possible to solve. That's always going to be synthetic division. Okay, so real quick refresher of direct substitution. If I have f of x is equal to x to the fourth minus 2x plus 7 for when x is equal to 2. I just need to simply plug that in. So f of x, well that's f of 2 now, is equal to parentheses. So I have 2 in parentheses. I'm going to raise that to the fourth minus 2 parentheses 2 plus 7. So I just put in red the number that we're plugging in. So f of 2 is equal to 2 times 2 times 2 times 2. Well, that's 2 to the fourth, which is 16, minus 4 plus 7. So I simplify from left to right. So f of 2 is equal to 12 plus 7, which gives me a grand total of 19. Okay, that's easy. You just plug in numbers. Okay, hopefully that makes sense. What we're going to do, though, with synthetic division is we're just going to get a quicker way to go about doing that. Okay, so let's refresh on synthetic substitution. I have f of x is equal to negative 3x to the third plus 7x squared minus 4x plus 8 for when x is equal to 2. So take a second. Write that down, and then draw your box. Okay. So I'm going to draw this box in now. Basically like the first quadrant, kind of how I think about it. And then remember, that number that you're solving for goes on the outside. Okay, it always goes out there because that's my multiplier. Then up top, you don't have to write this in, but I like to do it just to start until I get the hang of it because I need to understand that I need every single exponent possible. Okay, and it has to go in descending order. Okay, so now let's write the coefficient. The coefficient of x to the third, that's my negative 3. X to the second is 7. X is the negative 4. And my constant is my 8. Okay? Move this up. All right, so my first step is to drop down that negative 3 because I need somewhere to start. Okay? So instead of drawing all these arrows, I'm going to write and try to color code as much as possible. Okay? So my next step that I need to do is I need to take that multiplier and multiply it by negative 3. Okay, so I'm going to write that under 7. So I take 2 times negative 3, and I get negative 6. Okay, so I write that under that column. You do not have to put that 2 and negative 3. I'm just kind of trying to show you what's going on. Okay, so now my next step is to simply add straight down. So I'm going to take 7 plus negative 6, and I'm going to get a 1. Again, you don't need to write those numbers. I'm just trying to show you what you're doing. Okay? All right, so I'm basically done with that first column. Now what I'm going to do is I'm going to move on to the next one. So I have to take 2 times 1, and I get 2. Okay, that goes into the second part. Then I have to add straight down. So then I get negative 4 plus 2, which is equal to negative 2. Okay, hopefully you're following along. This is just going to take time to get the hang of it. So as long as you understand where we're getting these numbers from, it will click, I promise. Okay, now you take 2 times negative 2. to get -4 in the very last column. So then I just one last time add straight down to get a total of 4. I promise this will eventually become rather quick for you. Okay? So I'll give you a second to take that all in, finish writing that up. And we'll do a couple more. Okay. And you can always pause and go back if you need to. Next example, f of x is equal to 2x to the 4th plus x to the 3rd minus 3x squared plus 5x for when x is equal to -1. So now we're going to bring in a negative. So you got to be careful here. All right, synthetic division here, or synthetic substitution. Here we go. -1 goes on the outside, I draw in the box. I have to start with x to the 4th, so that's 2. X to the 3rd is 1. X squared is -3. X is just 5, and then I do not have a constant term, but I still need to put that in there. I still have to have basically a placeholder. I've got to have that, okay? Drop down your 2. And go ahead and start multiplying and adding. I'm not going to color code this time, so hopefully you can follow along. So -1 times 2, that'll become a -2. Add straight down, and I get -1. -1 times -1 is a +1, and then I add straight down. So I get -2. -1 times -2 is a +2. And then I add straight down and get 7. And then I take -1 times 7 one last time, and I get -7. I add straight down, and my answer to the function when x is equal to -1, this y value, this function now is at -7. Okay, so again, take a second to look at that. Make sure you know where these numbers are coming from. If you're unsure, ask a neighbor real quick. All right, let's do one more real quick for synthetic, and then we'll start graphing. Okay, we're going to graph a couple more today. All right, so f of x is equal to 3x to the 5th minus 2x squared plus x for when x is equal to, let's go easy and make it 2. All right, again, I'm going to make it real quick, and I'm going to use synthetic. So 2 goes on the outside. All right, now you got to be careful here. X to the 5th, x to the 4th, x to the 3rd, x squared, x, and a constant. I actually have to have 6 columns here, but I only have 3 terms, so I'm going to have 0 in a bunch of places. All right, here we go. My coefficient here is 3. I don't have an x to the 4th term. I don't have an x to the 3rd term. My x squared has a coefficient of -2. My x has a coefficient of 1, and I don't have a constant. That should be a C. I don't have a constant. So in all reality, this is going to make your numbers really, really easy and kind of nice to work with. So let's drop down 3. 2 times 3, that's going to be 6. Okay, add straight down. Well, 0 plus 6 is easy. That's just 6. Okay, then you get 2 times 6, which is 12. Add straight down, and you get 12. 2 times 12 is 24. Add straight down with -2 now, and that just becomes 22. And then 2 times 22 becomes 44. Add straight down, and you get 45. But I'm not done because I have one more placeholder, so 2 times 45 is 90, and you add straight down to get 90. Okay? So again, I can't reiterate this enough. It will click eventually, and this is just a quicker way to solve these, to evaluate these functions, okay? We can even, I'll show you this on Tuesday, we can even have a quick little race if you want to. You guys do the direct substitution, I will do synthetic, and I will show you how quick it is. All right, let's talk about one last thing before we actually start graphing some. We got to talk about end behavior. If you can understand a graph, x's are the horizontal, y's are the vertical. To the right for x's is positive, to the left it's negative, up it's positive, down it's negative. Okay? If you understand that, you understand end behavior. You just have to take a second to really think of what's going on. If you don't want to think sometimes, let's cheat. Let's use what we wrote down yesterday. For even degrees, and this is true every single time, whether it's 2, 4, 6, 8, 20, 1,000, whatever it may be, if it's an even degree. As x approaches positive infinity, as x gets bigger, your f of x approaches positive infinity as well. And then same thing, if x approaches negative infinity, your function approaches positive infinity as well. Think of the easiest case, a parabola. Whether it's upside down or not, it's going in the same direction. Okay? You just have to remember, if your leading coefficient is negative, your behavior is the opposite. Okay? So kind of cheat when you remember these things. Okay? So for your odd degrees, as your function approaches positive infinity, what happened to your
Jared
x?
Donald to the front office, please. Jared Donald to the front office.
Sorry, there was a little announcement. All right, so as your function approaches positive infinity, while your x's were approaching positive infinity as well. And then as your function approached negative infinity, your x approached negative infinity as well. Okay, think of a line. If you graph a line, as your x's get bigger, your y's get bigger. As your x's get smaller, your y's got smaller. Okay, that's end behavior. And again, just remember, your leading coefficient, if it's ever negative, you're changing your behavior signs, basically. Okay? All right, so hopefully end behavior is starting to click a little bit more. All right, today's assignment, you have to graph. Okay, so these ones, like I said yesterday, they're either going to be similar to a line, but just a little bit, curvier in the middle, or a parabola with some more curves in between as well. It just depends on what your exponent is, but they're still going to look roughly the same. All right, so let's just quickly graph f of x is equal to negative x to the fourth. Okay, so just literally put in a t-chart. Always pick -2, -1, 0, 1, and 2. You do need to have 5 points this time. All right, when you plug in -2, you have -2 raised to the fourth. Well, -2 times -2 times -2 times -2 is going to be, oh wait, looking at the wrong one. It's going to be -16. Okay, -2 to the fourth is positive 16, but you have a negative out in front, so it's -16. Then you have negative 1 to the fourth, which is just negative 1. 0 to the fourth is just 0. Then negative 1 to the fourth is just negative 1 again, and then negative 16. So when it's x to the fourth, it still really looks like a parabola in that it's still rather symmetrical, especially if you have nothing else with your function. It looks pretty symmetrical, okay? So let's just graph this real quick. I'm just going to go by twos. So 2, 4, 6, 8, 10, 12, 14, negative 16, 2, 4, 6, 8, 10, 12, 14, 16. 2, 4, 6, 8, 10, 12, 14. All right, negative 16. All right, let's graph this. So negative 2, negative 16. I'm going to go over my point here. Sorry. Negative 1, so here it's a little weird. It's really small, but if you go by ones, you'll be able to see it just fine. 0, 0, 1, negative 1, and then 2, negative 16. Okay, so it looks just like your normal parabola. Okay, so finish graphing that real quick. Okay, so hopefully you have that graph. So now let's talk end behavior. So as your x's go off to the right, so to positive infinity, your function goes down. So your function or your y values are approaching negative infinity. Okay, so then the other end behavior is as x approaches negative infinity, so as it goes to the left, your function approaches negative infinity as well. So if you look back at those cheats, it makes sense when your leading coefficient is negative, you're switching the end behavior. Okay, so hopefully that makes some sense. All right, one more and then you'll work on the homework together. So you have f of x is equal to negative x to the third plus 3x. Okay, this graph looks a little funky because it's not a line, it's not a parabola, it's kind of like that little serpent we looked at yesterday. So let's do the t-chart. So negative 2, negative 1, 0, 1, and 2. Plug it in. I'm just going to write up the numbers here, but just make sure you're plugging it in and being careful with the negatives. So I'll do the first one actually. Negative 2 to the third plus 3 times negative 2. So you get negative, and then negative 2 times negative 2 times negative 2. Well, that's going to be negative 8, but then don't forget about that negative out in front, and then you have minus 6. So this becomes 8 minus 6, so we get 2. Keep going and plug those numbers in, and then make sure you match up with these numbers here. I'll give you guys a little bit of time to get that to. Okay, so hopefully you have that down. I'm going to erase this so I can graph it on the same board here. All right, draw in your coordinates here. So we got 1, 2, 2. Actually, let's go by threes, just so you can see a little bit more of the shape. All right, so negative 2 up 2. Then I got negative 1 down to negative 2. 0, 0. 1 up to 2. And then 2 down to negative 2. So it looks really weird, right? It looks kind of like an X right now. But you got to remember, you got to go in order, okay? So I started at negative 2, 2. So I'm going to go through that point first. And then you just kind of got to trace this. So you go down, then you go up again, then you go back down. So it looks like that weird serpent. But this one kind of has more of a curve to it, okay? So there's this graph. So let's talk about your end behavior. So as x approaches positive infinity, as your x go to the right, what do your y's do? Well, they approach negative infinity here because your leading coefficient is negative. So then as x approaches negative infinity, or it goes to the left, your y values approach, they approach positive infinity because they're going up now. Okay, so there's how we're going to graph these in a nutshell. So there's really no, set way of what we need to do each time. You just have to, plot the 5 points in your T-chart and go from there. Okay, so hopefully that makes a little bit more sense than what it did yesterday. Okay, so the rest of the time you're going to work on your homework. Please make sure you're actually working, you're getting questions answered, and then feel free to shoot me an email if you're still really stuck on something. Otherwise, we'll go over everything on Tuesday when we get back. Have a good long weekend. We'll see you on Tuesday.